This maths question is from the C1 module of the CCEA specification, and it refers to a curve shown in the diagram. You have to find the values of P and Q, and we're told that the curve crosses the y-axis at C, and we have to find the coordinates of C. In this question, you have to find the values of P and Q. They give the function for you, and you can see that when x is 3 and x is minus 1, y has the value 0 because the curve crosses the x-axis at 3 and minus 1. This means that I could write 0 is equal to 3 plus p and 3 plus q all squared. It also means that I can write 0 is equal to minus 1 plus p and minus 1 plus q all squared. For this here times this to equal 0, either 3 plus p must equal 0 or 3 plus q must equal 0. If 3 plus p equals 0, then p would equal minus 3, and if 3 plus q squared is equal to 0, then 3 plus q must equal 0, and that would give rise to q being equal to minus 3 as well. Similarly, when you have put in minus 1 into the equation, either this is 0 to make this product 0, or this is 0 to make the whole product equal to 0. So that would mean that p is equal to positive 1, or q is equal to positive 1. So basically, we want to know p is 1 and q is 1, or if p is minus 3 or q is minus 3. P can't possibly have two values and q have two values when it's just a quadratic curve. So what we're going to do is we're going to look at the curve, and we can see that when x is 0, the y value has to be a negative number. So I'll try out the combination when p is 1 and q is minus 3. I read out the equation, and I know that y has to be a negative answer when x is 0. So I put in zeros for x's, and I try out 1 for p and minus 3 for q. Minus 3 squared is positive 9, be careful of that. And 0 plus 1 is 1. For this combination here of p being 1 and q being minus 3, I get an answer of positive 9 for y, but we want y to be a negative number. So I'll check with the next combination. Could p have been minus 3 and q been positive 1? So x plus p, x plus q all squared. Put in 0 for x again, and put in minus 3 for p and 1 for q. 0 plus 1 squared is 1. 0 minus 3 is minus 3. Minus 3 times 1 is minus 3. This gives me an answer of minus 3. And that there is below the x-axis. So my conclusion is that p must be minus 3 and q must be equal to 1. The next part of the question says that the curve crosses the y-axis of C and to find the coordinates of C. This is the curve given in the question. The curve crosses the y-axis here, and this here is given by C in the question. The curve crosses the y-axis when x is 0. So if y is equal to x plus p, x plus q all squared, and if y equals the c value when x is 0, then put in 0 for x. We already know that p is minus 3 and q is 1, so c is equal to 0 minus 3, 0 plus 1 all squared. 0 minus 3 is minus 3, positive 1 all squared is 1. So c is equal to minus 3, and the coordinates of where the curve crosses the y-axis is 0, minus 3.